Hello, and this time I am looking at quadratic sequences. Now in GCSE you're more likely to get a quadratic sequence where they give you a quadratic nth term rule, so maybe 3n squared minus 2n plus 5, and they say generate the first 5 terms of the sequence and maybe the 27th term, I don't know. Now you can actually do this really easily on your calculator if it has a table function. Menu, and for me it's menu 9 for the table function, and I get f of x. And this is saying a function of x, and okay, I've got a function of n, but as long as I write it in with an x, then it will still work out the same. So 3x squared minus 2x plus 5, that's my nth term rule going in. Now my calculator will do 2 at once, which is really useful when you're doing things like parametric equations, but that's in A levels. Don't worry about that if you're not there yet. So I'm just going to leave that blank and just press equals. Where do I want to start? Well, I wanted the first 5 terms. So yes, start at 1, yes, end at 8, and yes, a step of 1. That's all exactly what I wanted. But if you wanted, let's say, the 5th, 6th, 7th, and 8th term, you just say start at 5, and go to 8 and go in steps of 1. But as I don't want to do that, let's put it back to start at 1, go to 5, and here are the first 5 terms of the sequence. They would be 6, 13, 26, 45, and I'm going to have to scroll down for 70. So there's my sequence. But if you remember, I also wanted the 27th term. Now to do this one, I may as well just calculate it manually. So go back to my normal menu, and I'm just going to do 3 times 27 squared minus 2 times 27 plus 5. And the answer is 2,138. Now if you're not sure about that substitution, if you're not very good at substitution, then you can always put it in like this. You can either say 27 and store it as a, and then you could type 3 alpha a squared minus 2 alpha a plus 5, and it will just substitute that for you. Or if you've got a calculator with the calc button, you can just type that in, and you can say calc, and okay, it says a equals 27 because I've just told it it was. But if I hadn't done that, it might say a equals 3 or 0 or whatever it last stored as a, and now I can say no, yeah, put it as 27, and I can correct it and say yes, use 27, and it will work it out. So if you're not very good at substituting, you can type it in with a letter and ask it to calculate it for you, either by storing it beforehand, or if you've got the calc button, typing in calc and then telling it what that should be. Good thing about the calc button is if I want to do another one, if I want to know the 95th, I can just type in that and it will work it out. And if I then want to do the 87th, yeah, you can just keep asking it to do it again for a different number. So if you've got a big list of things you've got to substitute into the same equation, you can use that. So that's more likely what you're going to get if you see it in GCSE, is they'll give you the quadratic rule and you have to work out a term or a number of terms. But it is important that you can also look at a quadratic sequence and work out what that rule is. It's a little convoluted, but I'll go through this example to show you how to do it. So just like when we do a normal nth term rule, and if you can't do nth term rules, then you need to be able to do these first. So go and find the video I've made about finding the nth term rule. And similarly to that, what we do is we look at the term to term rule. So if we do that, this is plus 3, and then plus 7, and then plus 11, and then plus 15. Now normally, if it was an arithmetic sequence, this would all be the same. It would be plus 2, plus 2, plus 2, plus 2, and we'd work out the nth term rule. But these term-to-term rules are changing, but it's changing with its own term-to-term rule. So we call these the differences, because these are the differences between all of the numbers. And so we're now going to look for the second differences. So we would look at this and say this is plus 4, and then this is also plus 4, and oh look, this is also plus 4. The fact that these second differences are the same is the clue that this is possibly going to be a quadratic expression. And so what I want to do is I'm thinking n squared is going to feature into this. But what if there's a number in front? Like before I had 3n squared. Well, we can get that number from the second differences. And it is actually half the second differences. I'm not entirely sure why. I haven't sort of sat down and played with it and looked at why that's the case. Maybe that's something you can do if you feel inclined. I'm just happy saying that if I get this and I want to find it, then I know to do half the second difference as the coefficient, the number in front, of the n squared. Okay, so if this is likely to be my sequence, let's write it out. What is the first term for 2n squared? Well, we could get the calculator again and type it in the table function, but I think I can do these. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared is 25 times 2 is 50. Now I know what you're going to say. It hasn't worked. And you're right, 2n squared hasn't worked. It's not given me the right sequence. But if you know how to do nth term rules, you know that it had this for this. We will need this. Oh no, we won't need this one in a moment. If we wanted to nth term rule this bit, we'd say, oh well, look, it's 4n. It's going up by 4 each time. It's 4n. But wait, that wouldn't give me the right sequence. It's giving me 4 and 8 and 12 instead of 3 and 7 and 11. But I can adjust that because they're all one smaller. And we're going to do exactly the same thing. We're going to say, how much adjustment do we need? But it is different for each number. But don't worry, it will come out in the end. So if we say, we need 4, but we've got 2, that means we need an extra 2. Here we've got 7. We need 7. I mean, we've got 8. We need an extra. No, we've got 1 too many, haven't we? So here we've got 8 so far, but that's more than what we needed. Here we had made 2, and we needed 2 more to get 4. But here 7 take 8. We actually have too much. 14 take 18, we've actually, again, got too much. We've got 4 too many. Here we've got 7 too many, and here we've got 10 too many. So it doesn't look like it's working, but it is, because if you look at this, the bit extra we need to add on, is an arithmetic sequence. Look, it's 2 to minus 1, that's minus 3, that's minus 3, that's minus 3, that's minus 3. So this is the normal nth term rule. It's going down by 3 each time, so that's going to be minus 3n times table. But of course, minus 3n starts at minus 3, and we want to start at 2. So this sequence is minus 3n plus 5. Let's just check it works for the second term. Minus 3 times 2 is minus 6, plus 5 is minus 1. So it's working. So the sequence that we want is made up of these quadratic numbers, these squared numbers doubled, and then the extra bit that we need to add on, or indeed take away, is this sequence, which means the whole of this are these two things added together. 2 and 2 is 4, 8 minus 1 is 7, these added together is 14, and so the whole answer to the sequence, this term's rule, is 2n squared minus 3n plus 5. We're just going to put the two bits together. The quadratic bit, which we got from the the second differences, we halved the second difference, guessed that it will be n squared, and wrote out what we got. We then subtracted, we did our sequence that we wanted, take away how much we have so far, and we got what we needed, which turned out to be an arithmetic sequence that we can just do the nth term rule for, and then we added those two things together. We just put that bit with this bit, and we got, oops, didn't mean to do that. Let's move it back. There we go. And we got the sequence for the nth term rule for our sequence as 2n squared minus 3n plus 5. Now, if you've got a few of these to practice, it might be that you have to go back in the video and watch my step-by-step again for doing yours. But in a quick summary, you work out your differences and your second differences, which should be the same. You half the second difference and write that half number times n squared. Write out the answers to that sequence. Do your sequence from the question, take away what you've got so far, and write out the new sequence from all the subtractions. This should be an arithmetic sequence, which you can find the term-to-term rule for, and therefore the nth term rule. And then your answer is these two things mushed together. If you have any issues with that, any questions, pop them in the comments, but otherwise, cheerio.